Today we're going to be working on Leetcode question number 315. Count of smaller numbers after self. Given an integer array nums, return an integer array count where counts of I is the number of smaller elements to the right of nums of I. So if we have been given 5, 2, 6, 1, the answer is going to be 2 because there are 2 more smaller numbers to the right of 5, and then 1 because there is one more smaller number to the right of 2, 1 because there is one more smaller number to the right of 6, and 1, and then 0 because there is no more smaller number to the right of 1. And similarly, if there is only one element, it's going to be 0. If there are exactly the same elements, it's going to be both of them do not have smaller numbers to the right. The way the algorithm is gonna be like we're gonna be using the merge sort for this one before implementing the merge sort. So in the merge sort, we're actually gonna be looking at the total number of elements smaller than smaller to the right. So for this one, we need to keep the value and the original index. Because we don't want to lose that when comparing total number of elements to the right. So we're gonna use a class. Let's call this class as array value with the original index. It's gonna keep the value and it's gonna keep the index. Okay, and we can make a constructor saying that this array value with original index is gonna take two things, which is the value and the original index, and then the value is gonna become equal to value, and this dot original index is gonna become equal to original index. Oops. Okay, what we're gonna be doing in the merge sort is like basically we're gonna have a sanity check where if the nums is equal to null or the nums dot length has become equal to 0, we're just gonna be returning a new, like an empty linked list, and the type is gonna be integer. Okay, now we're gonna keep record of the total number, basically the length of the nums, and also our result is gonna be equal to new and up to the size of, like, it's the size of the result is gonna be the n. Okay, now we're gonna fill up this like the class objects array value with original index. So for that, first of all, we want to set it up. So array value with original index, let's call it new nums. So there is new array value with original index of size n. In order to populate it, we're gonna be iterating I is equal to 0, I is less than n, I plus plus. For that, every single time our new nums of I is gonna be equal to this new array value with original index and that is gonna be the nums of I and its index, the value and the index, just as the name says. Okay, now we're gonna be using a helper function called merge, sort, and count. So we are sorting the the array just like using a merge sort, uh, and then at the same time we are counting how many elements are there to the right. We're gonna be sending this new nums, which has basically the information of the value and the original index. We're gonna be sending the starting index and the ending index, which is n minus 1, and then the result, which is gonna be filled up. Okay, okay. Again, the result is an array, but what we need to send back is a list of integer. So the last thing we want to do is to convert it back to result integer is equal to new linked list of integer, and then we're gonna fill it up again. This is because we're in Java, and that's how we can convert. Okay, new nums, or basically sorry, the result, and the result integer dot add the value of the I. That's it, and then we're gonna be returning the result integer. Okay, now back to our main function here, which is basically we're trying to merge the arrays, and at the same time we're trying to count the smaller elements to the right. For this one, let's define this function. Okay, it's a private. We're not sending anything back because everything is gonna be filled up in result. Merge, sort, and count. Okay, so we're gonna be taking the list of this array value with original index as an array. Let's call it nums. Okay, and the start and the ending index. So int start and int end. And the last thing is an array which we need, where we are gonna be putting the results. Okay, sounds good. Okay, the first thing is that the base case is gonna be that if the start, because we are doing the merge sort, we're gonna say that if the start becomes bigger or equal to end, that means just return. Okay, okay, otherwise calculate the midpoint, which is the start plus end divided by 2. Okay, then again merge sort from start to mid and mid to end. Same thing, nums start to mid and oops, merge sort and count nums mid plus 1 to n. Okay, so once we have that, now we have individual elements. We would be able to compare them in order to sort them. So we're gonna have some variables here. Left position is gonna be equal to the start, and the right position is gonna be equal to mid plus 1. Okay, now we're gonna have a list of like a linked list of uh, these this class object array value with original index idx. Okay, uh, we're gonna call that as merged new linked list. Okay, okay. uh, and the other thing we want to do is, because we want to keep it efficient, and we don't want to compare every single time when we are merge sorting, and we don't want to calculate every single time how many one element to all the elements to the left in order to increment the result. What we're going to be doing is, like, we're going to be calculating what are the total number of elements, the right elements, which are less than the left elements. So we're going to call int number of elements. So number of elements in the right array, right, value, sorry, less, let's call it less uh, than left array, which is gonna be equal to 0 at the beginning. Okay, now first we wanna have a while loop where the left position is less than the middle point and the right position is less than the end. So while the left position is less than the mid plus 1 and the right position is basically less than equal to end. While we are in that category, what we're gonna be doing is, like, we're gonna be comparing the values, right? And if the value of, like, the nums of left position dot value is greater than the nums of right position dot value, if that is the case, we want to update this this flag, or this element where we were saying what are the total number of elements to the right which are less than the left element. If that is the case, first thing we want to do is to update ELEMS right array less than left array. Okay, okay, and then we want to add that like, just like in a merge sort, we add the smaller element, the element which is smaller to the right place, right? That's what we do in the merge sort. Whenever we find the smaller element, we put it into uh, the merged array, right? Merge dot add. Now for that, you're gonna have a nums of where the right position. So we're still using the nums, so that actually we actually put them based on their original index, and then we're going to increment the right position. Okay, if that is not the case, if the, let's say, if the left element is not greater than the right element of the separated arrays, and in that case, uh, all we have to do is to, again, we're still gonna be putting the result into the, like the left position into the merged, like we're gonna be putting the value in, we can either use, because so if the value is not greater, right, if the value on the left is not greater, that means the value on the, either the values are equal, or the value to the right is greater, right? So we're gonna be putting, uh, like, just like we're gonna be continue doing the merge sort and putting the left position element to the merged array and incrementing the left position. But one more thing we want to do other than that, that uh, we want to update the result. So because we are keeping a record of that, so in this case we know that the left element is gonna be getting pushed to the merged array. We want to update the result of that. So the result nums of the left position dot original index plus equals to what we are saving here. Okay, and now we can just merge dot add. This time it's gonna be the left position, and then we can increment the left position. Okay, so now we are done with the, if we have equal number of elements to the right and the left, we are done over here. But that is not always the case. So if we are left with some elements in the left array, right, left position is less than mid plus 1. If that is the case, again, we already have a record of this total number of elements to the right array less than the left element. So we're gonna be just using that. We don't have to iterate the right array one more time. We just have to, we have the record of that, so we're gonna be adding it to the result. Okay, so the result of nums of left position dot original index plus equals to number of the same thing. Okay, and also we're gonna put it into the merged add nums of left position, and then we want to increment the left position. Similarly, what if we are left with some elements in the right array and we are done with the left array? Right position is still less than equal to n. We're gonna do very similar stuff, but this time we don't have to add these elements to the right, because it's a merge sort and we are already coming from bottom up approach. So we are done with that. We don't wanna be adding or fixing anything in this one. So all we have to do is to add, put the result into the merge dot add nums of right position and then the right position plus plus. Okay, now this is where, like, So now in the end we're just gonna be copying uh, the merge back to the original array. So for that we're gonna be saying that let's start let's our position or the index is equal to the start, and for every array value with original index, let's call it m inside the merged. All we have to do is the nums of that position is gonna be equal to that m, and then we can just do it in one line. Cannot find the sample num, should be nums. Cannot find another symbol here. Okay, so this is what original index is. It's always orig index. Okay, looking good. And it works.